Good morning, children. So, today we are going to continue with chapter 1 Chemical Reactions and Equations. The topic of this chapter is corrosion of metals, and that's the last topic of this chapter. So basically, let me make you understand what is the objective of today's lecture. We'll be learning about the definition of corrosion. We will be also learning about the conditions necessary for the corrosion to occur and various metals which undergo corrosion, which do not undergo corrosion. And very important to understand corrosion, we have an activity, and definitely you can expect a board question on this activity. So here we go. So basically, what is corrosion? Let me ask you, have you seen iron articles getting corroded? What exactly it means? They change their color from brown. They become flaky. And sometimes you might have also seen the silver ornaments which your mothers wear. It becomes black after some time. And in olden days, we used to have copper coins, right? And those copper coins used to develop a green coating over it when left for a long period of time in exposed air. So, what are all these observations? Yes, very true. All these observations are just because of one process happening in nature, and that's what we're going to talk about is corrosion. So we can define corrosion in simple words, a slow destruction of metals. I said a slow destruction of metals when they interact with the environment. So basically what is present in the environment which is corroding, which is destroying these metals, their layer, and they are changing their color, their texture. They are becoming dull, they are no more shiny, they are no more bright. Yes, the presence of moist air. So moist air means there should be a presence of oxygen. Along with that, it should be the presence of moisture, that is water. So this definition of corrosion you can learn. Next we go. So we need to understand what are the necessary conditions for corrosion to happen. As I told you, there should be the presence of oxygen in the air as well as the moisture. But remember, only if both these conditions are satisfied, corrosion occurs, otherwise nothing happens. Now, another important board question what you can get is, explain why the surface of some metals acquire a dull appearance. As I said before, that corrosion will destroy the texture of the metal. It will no more remain shiny. As I said, copper may develop green color, silver articles will become black, and the brown color of the iron becomes reddish brown. It becomes flaky. It starts destroying. Even you might have seen the iron pipes, right? After some time, the iron pipes get eaten away. So what's that? What is eating away the metals? That's nothing but the moist air. Okay, so this answer you can quote for this particular question. Okay, now another very important thing, sometimes they might ask you in board exam, what are the metals which will not undergo corrosion? I said which will not undergo corrosion. So we have learned the reactivity series in the previous lecture of the displacement, and I gave you the talk word terms to remember the reactivity series. Hope you remember, otherwise go back and refer it. So remember, gold, platinum and chromium are the metals which are placed below hydrogen, and they are very, very inert. They don't react at all. So even they are so inert that they can't be corroded. So that's another important question if they ask you what are the metals which do not undergo corrosion. So now we are going to learn more about corrosion step by step when I'll talk about the different types of metals. So in your syllabus you have 3 metals. One is iron, the other one, as I said, is your silver, and the third one is copper. So, as I told you before, silver articles become black. Yes. Two very important things you need to keep in mind. Silver reacts with sulfur in the air to form a silver sulfide layer, as well as it reacts with oxygen to form silver oxide. These two layers combine together to give the black appearance to your silver ornaments. That's again because of the corrosion. So in case in exam you're getting why, the question can be, why do silver articles become black when left for some time? So that's the answer you need to write. Okay, next I told you in olden days they used to have a copper coins, and copper coins when left for a long time they develop a green coating, and that green coating is because it reacts again with moist air, and particularly the component with which they react is not only oxygen but carbon dioxide as well. And the green coating is because of copper carbonate. But in exam, they usually ask you the formula. So the formula is hydrated copper carbonate. Why do we use the term hydrated? Because moisture is present. So remember this formula, CuCO3 dot CuOH whole twice. And you already know the crisscross method, which I repeated in the first lecture of mine, the recap of class 9, so you can easily understand why have we used here OH whole twice. So that's the reason for copper becoming green. Now let's proceed for iron articles. Yes, the common term for the iron articles is rust, and we say iron gets rusted. So another very important question, what is rust? So rust is the brown flaky substance which develops on the iron articles because it reacts with oxygen and the moisture to develop a brown flaky substance called as rust. And another very important thing, you should know the formula of rust, and commercially rust is also known as hydrated ferric oxide. When I say ferric, that means iron is in +3 state. So the formula becomes Fe2O3.XH2O. You must be wondering, what is this X? Yes, these X are the molecules of water which have attacked along with the oxygen on the surface of iron, and hence the chemically, I must say, not commercially, the chemically rust is also known as hydrated ferric oxide. So don't forget to add XH2O. It's very, very important. Okay, the heart of this topic, yes, this activity, which is not there in chapter 1. Remember, note down my words. It's in chapter 3, metals and non-metals, because this topic of corrosion is again repeated in chapter 3. So instead of learning out there, I'm going to teach you here itself. So listen very, very carefully, because you get lot of questions on this activity. So this activity, it will be a direct board question. How can the rusting of iron be proved with an activity? It's a 3-mark question, and this is how you need to tabulate. Please make a note of this tabulation in your notebooks. You need to complete all your notes from this lecture, right? So here we go. We have 3 test tube 1, 2 and 3. But the conditions in all these 3 test tubes vary. So what's the condition? In test tube 1, we have moisture, that's water. Of course, we are talking about iron. We are talking about what? Rusting in iron, Fe, right? So we are going to take iron nails. And we have air. We have taken both this water and nails in a test tube. And of course, air is going to be trapped in it. It's understood, common sense. And then later on, we're going to cork it. So what happens? Tell me, what did I tell you before? Of course, yes, I told you that it's a moist air which is going to attack and then only the rusting will happen. Are these both conditions present here? Of course, yes, we can see the presence of water and the presence of oxygen, and so we can say that moist air is present and rusting is going to happen. Fine. So the iron article becomes reddish brown in color. And if I say why it becomes reddish brown, those iron nails, yes, it's because of the coating of hydrated ferric oxide. Okay, fine. In the second test tube, I have used boiled water. What is the significance of boiled water? Absence of oxygen. We don't want any oxygen because we have to prove in this activity that the presence of both moisture and oxygen will only lead to rusting. So when boiled air is present, its absence of oxygen, iron nails are present. And remember, we have taken a layer of oil because the main role of oil over here is to cut down, I said cut down the supply of oxygen because we don't want any oxygen to attack on iron nails. Tell me, are both the conditions present here? Of course not. It's only water which is present, but oxygen is absent. So what do you infer? I'm sure you might have thought in your mind by now that rusting is not going to happen. Very true. So no rust formed. In the third test tube, we have again iron nails. Of course, in all these test tubes, we are corking it. Okay. So again we have iron nails, and this is something new for you, that's anhydrous calcium chloride. And please make a note, anhydrous calcium chloride acts as the moisture absorber. It absorbs all the moisture from the compound. You might have seen when you get a new shoes, when you get maybe some woolen clothes, right? In that some packet is there kept inside it. What's that packet? That packet is anhydrous calcium chloride. And often such type of packets are often kept with leather articles because we don't want our leather to get spoiled, right? So we want to avoid moisture. So that's the reason of anhydrous calcium chloride using over here. We don't want any moisture. We don't want water. Of course, we want air to attack. That means oxygen we need. And of course, cork it. So what is absent here? Moisture. Very true. So are the conditions satisfied? No. One condition is absent. That is moisture not present. But oxygen is present. What do you think? Click. Yes. Of course, yes. No rust formed. So this activity helps us to understand the conditions of rusting. Hopefully you understood this lecture, and the next video of mine will be talking about the rectification of this rusting, various methods which are both in chapter 1 and chapter 3. So we'll do it together. So have a good time and note down all these points in your notebook. Make the notes, right? If any doubts, please, you are free to call me at any time. Okay, that's all for today. Thank you.